Hello.
Hello.
I have Abby here with me to talk about area. So we are going to just do a quick review of what we know about area of a rectangle and area of a parallelogram, because I know you've done this work before. And so we're going to combine these two into one review for you today. And then there'll be new information for you for next week. Okay, so we're going to look at our area of a rectangle material. And here I have it in front of me. Sorry, I have a whole bunch of material set out that I was getting ready for our lesson. So here is our rectangle. And when we are doing area of a rectangle, we know that we need two measures. We need the measure of the long side, in this case, this long side and this short side. It doesn't matter which one's long and which one's short. They could go this way too. We just need the measure of two of the sides of a rectangle. And we know that it's not enough to just have the horizontal lines or the vertical lines. We know we need to have both the vertical and the horizontal lines to help us to find the area. And when we do this, we know that we can count how many units are along the bottom, which we call the base. And we need to know how many units are along the side, which we call the height. So when we're finding area of a rectangle, if we know those things, area of a rectangle is equal to the number of units across the base, B, times the number of units along the side, which is the height. This is the base, B, and this is the height. So for our example here, we already know this one because we practice with this one all the time, but let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units. And then we're going to multiply it by the units along the height. 1, 2, 3, 4, 5. 10 times 5 equals 50. And we call these units. And they're squares. They're square units. This rectangle has an area of 50 square units, and we label it like this, 50 units squared. I'm going to show you a picture of what your journal should look like with this. I'm not going to do it right now because we're going to also review our parallelogram, and then I'll show you both journal entries in a picture down below when it's time for you to look at your follow-up. You're going to be doing a few examples of a rectangle for me and a few examples of a parallelogram. Okay, we're going to set that over here out of our way, but close enough we can bring it back if we need to. Okay, here I have another polygon. This is a quadrilateral. It has 1, 2, 3, 4 sides. Four-sided polygons are called quadrilaterals. And this is not a rectangle quadrilateral. This is a different kind of quadrilateral. This has one pair of parallel sides here and another pair of parallel sides here. So we call it a parallelogram. It's a fun word to say. Parallelogram. It's just a fun one to say. Okay, so for this parallelogram, we need to look at what we know. We normally talk about, can we count up the squares? And when we look here, we see, oh, there's all these partial squares. Can we count up the partial squares? No, we have to do something different. We have to take this and transform it, change its shape into another shape so that we can see how many square units there are. So here I have another parallelogram. It is the same. If you remember when we talked similar, congruent, equivalent, we talked if a shape is the same shape and the same size, same shape, same size, that is congruent. They're also equivalent because they take up the same space, but these are congruent. Same shape, same size. Okay, now these are the same, so we're going to use this one. This one's divided. It has a piece that has been cut so we can explore with it. This is a parallelogram that we can't count up all the squares. But Abby, can you help me transform this parallelogram into a shape that we can count all the squares on? She broke off the piece that was attached on this side over here, and she moved it and stuck it on right there. Now look, all of those pieces of squares now have whole squares. And now we can find the area. Now that we have it as a rectangle, we can use our formula for area of a rectangle for that work. What was the area of a rectangle?
Base times height.
Okay, let's count up the base of this parallelogram, or this rectangle that we've just made.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
The parallelogram made a rectangle with a base of 10. Count its height.
1, 2, 3, 4, 5.
Oh, the parallelogram made a rectangle with a base of 10 and a height of 5. We already know how to find the area of a rectangle with a base of 10 and a height of 5. So we could find the area of it as a rectangle. Let's see if we can figure out how we would find the area of it as a parallelogram. Let's look at our whole parallelogram. Did the base of this parallelogram, it's hard for you to see, I'll do it this way. Did the base of the parallelogram change when we moved that piece? No, see, that is still the same, the base. The base is still the same. Okay, how about the height? Did the height change when you moved that piece from one end to the other? No, if we lay these on top, the height is the same. So that must mean that we find the area of a parallelogram the same way we find the area of a rectangle. Base times height. One thing you have to make sure you're doing is that this here is not the height. This is a side. The height is from the top to the bottom on a vertical line. So you can't use this side as your height. It's a side, not a height. Okay, let's label this. So the base of our parallelogram is here and our height is here. Can you grab me the ticket basket? It's just out of my reach. Base and height. Right there. Okay, let's write our formula for this. The area of a parallelogram equals base times height. And for this one, what was the base?
10.
And what's the height?
5.
And what is 10 times 5?
50.
50 units. And what kind of units?
Squared.
Squared. We're counting up square units. There's our area of a parallelogram. Area of a parallelogram is base times height. And our answer is always unit squared. Let's check what we had here. Bring our rectangle back in. Look at that. The formula for area of a rectangle is the same as the formula for area of a parallelogram. We find them the same way. Okay, for your follow-up, you're going to write these formulas just like I do in my journal on your journal page. And then you're going to draw a couple rectangles in your journal and find the area of them, and draw a couple parallelograms in your journal and find the area of them. And that is your follow-up for review of area of a rectangle and area of a parallelogram. Thank you. We'll see you next time.